In the last example, we were finding limits using graphs. This particular example, we're going to use a table instead, and this table is actually going to use the same expression as the last one, so our limit's not going to be any surprise here. It's still going to be 12, but we're just going to show it in a little bit different way from the last one to see that we can get the same type of answer. So we're going to do this one by tables. Now, if you'll notice on my calculator, I have entered the expression in for y1, the x cubed plus 8 over x plus 2. So I put that in right away, and I might go to my graph to see it. I don't see it very well because I don't have a good window on this one. But what I'm going to do is I want to get a table of values here. And you'll notice this table of values I have, these are the ones that I'm going to use, and it's getting closer and closer to the actual value we're looking for, to that x value, from both different directions, and hopefully they'll agree here. Now, normally for your tables on your calculator, if you're going to use the calculator to find tables, you go to second graph, and you'll have this table that is really not of much use to us right here, just because the x values go up by whole numbers. And you notice we do have -2 there, so we know that that one, that's an error if you are just entering it into your calculator in that way. Whoops, I wrote it in the wrong spot there. So that one was an error. But if I use a different setting for my table, I can actually type in the numbers that I want. So I'm going to go back to second window, which is table setting. I'm going to go to independent variable as ask. When I go back to my table function now, if I go second graph, then I can just start typing these things in. So I can type in -1.9, -1.99, and -1.999. And as you'll notice, these numbers are getting closer and closer. I've got 11.41 to start with. I've got 11.94. This one was 11.994. And so it looks like it is getting pretty close to 12. That's because that's what we found in the last one, is it's really close to 12. But let's go on the other side now too. This -2.001, -2.01, and -2.1. As you can see here, same thing is happening. I go back away from it a little bit. 12.61, 12.06, and then here I'm getting 12.006, and so that one's moving closer as well. So with this method, I can again find that this is it should be a limit of 12, and you could get even closer if you wanted to with these numbers, if you really wanted to make sure. But that's a method using a table that you can do to find the limit of any particular expression.